students, how are you? I hope you all are doing great today. My name is Renu Rathi and today we'll be learning our very interesting topic, that is Basic Geometrical Ideas Part 1. Now, in this chapter we will learn about point, line, curves, polygons, angles, triangles and quadrilateral. Now let's start with the introduction. The word geometry originally came from the Greek word geo, means earth, and metron means measurement. Therefore, the word geometry means measurement of earth or is the science of properties and relation of figures. Now, the necessity of geometry was felt when people started constructing buildings, measuring land for buying and selling and making geometrical figures. Now, the scope of plane geometry, that means the study of plane figures, lines, angles, triangles, quadrilaterals, etc. Now, let's start with the point. A point gives an idea of a location by making a dot by a sharp pencil on a paper, and it has no length, breadth and size. A point determines a location. A point has no dimension, that is no shape or size. For example, the tip of a compass, the sharp end of a pencil, the pointed end of a needle. Now, naming a point. A point is denoted by a capital letter of the alphabet like A, B, C. These are the points. The point will be read as point A, point B, point C. Example number 1. How many points are marked in the given figure? So, there are 8 points. Now, in example number 2, here we have to name the points marked in the following figures. So, in the first one, here is A, B, C, D, E, F, G, H. And in the second one is A, B, C, D, E and F. Now, next is check your progress. How many points are marked in the following figure? We have to name them. So, in the first one we have K, L, M, N, O, P, I, J. That's how you can complete the remaining one. Next is our line. A line is a straight path that extends indefinitely in both the directions and it is no end point. It has neither breadth nor thickness. Now, for example, the straight crease formed by folding a piece of paper is a physical example which is quite close to the idea of line. Other examples are edge of a ruler, edge of a table, etc. Now let's look at the properties of a line. In the first one, a line has no endpoints. A line can be named in the following two ways. 2 points, say A and B, marked on the line, and the line is named as AB and it can be read as AB. Now a line is also named by small letters of alphabet such as L. Second point says that we mark arrowheads on the two ends of any model of a line like this. These indicates that the line extends indefinitely in both the directions. Now we can draw unlimited number of lines passing through a point and we can mark an unlimited number of points on a given line. Now always remember how many lines can be drawn passing through 3 points, that is only 1. Only one single line can be passed through when the 3 points are collinear, otherwise there cannot be any single line passing through 3 points. Next is our intersecting lines and rays. If two lines have one common point, they are called intersecting lines. For example, two adjacent edges of a notebook crossing roads. These are our crossing roads. Multiplication sign. These are the examples of intersecting lines. Working rules, how to draw an intersecting line. Firstly, we will draw a line AB, then another line CD or M. They are intersecting at each other at point O, and O is our what? Point of intersection, and both the lines L and M are intersecting lines. Next is our ray. A ray is also part of a line which has only one end point and can be extended endlessly in one direction. Ray has no breadth and thickness, and light coming from sun or torch is an example of ray. Ray is represented by AB. A is the fixed point and B is the point where the ray can extend indefinitely. Now next is our parallel lines. When two points do not intersect each other and they have no point in common, they are called parallel lines. For example, the opposite edges of a ruler, rail lines, crossbars of the window, etc. are parallel lines. Here are the working rules how to draw parallel lines. We have to draw two lines L and M in such a way that when these two lines are extended in either direction, they do not meet at any point and there is no common point. So these lines are parallel and we write L parallel to M. Now in example number 3, in the given figure, we have to find out all the lines with names and all number of parallel lines. Line with names is L, M, N and P. All pair of parallel lines are L parallel to M parallel to N and L parallel to N. Next is our line segment. A line segment is a portion of line with two fixed points. For example, edge of a box, tube light, edge of a postcard are our examples of line segments. Here are our working rules that how we can draw a line segment. Let P and Q be any 2 points in a plane. L be the passing through P and Q. The portion of line L between points P and Q is our line segment PQ, and line segment PQ is denoted by this, and it can be read as line segment PQ. Next is our properties of a line segment. First point says that a line segment PQ has two endpoints, that is P and Q. We can draw one line segment joining the two given points. A line segment is completed if its endpoints are known. Line segment has length only. Comparison of line segments. In the joining figure, the length of line segment PQ is what? The distance between one endpoint and to the other endpoint. Here are our working rules to comparing two line segments. How we can compare? We will compare a line segment AB with another line segment PQ. We will put one end of the divider at A and open the other end that will coincide with B, and we will keep it open in that position. Now in step number 3, we will place one end of the divider at P. Now we will allow the other end to fall on the line segment PQ. There are three possibilities that the other end of the divider may fall on Q and AB is equals to PQ. The other end of the divider may fall in between P and Q, that means here somewhere, that means then PQ will be greater than AB, or the other end will be fall at N, that means beyond Q, that means AB is greater than PQ. Now measurement of a line segment. How we can measure a line segment? It can be measured by comparing it with the standard line segment, and that is known as a unit segment, and the number of times a unit segment is contained in the given line segment is known as length. For example, in the case 1, we have to mark on the same level of the line segment PQ. Here are the working rules that how we can measure the length of a given line segment AB. In the step 1, we will place the scale of the ruler, which has a centimeter, and then its edge alongside such that 0 mark on A. Then we will read the mark on the scale against point B, which is our required, and we can read it is our 6 centimeter. Case number 2. Marks on the ruler are not on the same level as line segment PQ. That means to avoid error in measuring, we will use a divider to measure the line segment. Here are the working rules how we can measure the length of AB. Firstly, we will open the end of the arms such that they coincide A and B exactly. After that, without disturbing the scale, we will place the divider on the scale, and after putting it on the scale, now we will read the mark against the end point, and it is our 5 centimeters. So the length of the given line segment AB is 5 centimeter. Next is our collinear points. 3 or more points in a plane are said to be collinear if they all lie on the same line. Next is our working rules how to draw collinear line. Step 1, we will draw a straight line L, then we will mark points on this line segment ABCDE. Thus we have drawn the collinear points on the line L. Now always remember, the points do not lie on the same line, they are called non-collinear points. Next is our concurrent line. 3 or more lines in a plane are said to be concurrent if all of them pass through the same point. In the adjoining figure, this figure L, M and N lines are our what? They pass through point O and they are called concurrent lines, and O is the point of concurrence. Here is our comparison between line segment and ray. Line has no definite length, it has definite length, it has no length. It has no thickness, line segment has no thickness, ray also has no thickness. Line has no endpoint, line segment has 2 endpoints and ray has 1 endpoint. It can be represented like this, line segment can be represented like this, and ray can be represented like this. Now let's start with example number 4. In the figure we have to find the following. Name the line L in other 2 ways. So the line L is CD or DC. Here we have to name the line M in 2 ways, that is our BD and DB. Here we have to name the line segment N, that is AD. Now in example number 5, in the adjoining figure we have to name these 3 non-collinear points, they are F, G and H. 3 collinear points, they are very good, E, G and H. Now lines which are concurrent at A, that is Q, R and O. Lines which are concurrent at F, that is Q and P. Let's start with exercise 6.1. In the first part, we have to choose the right option and fill it in the OMR sheet correctly. Number of rays that can be drawn from a given point is, we have to find out how many rays can be drawn from a given point, that is many. That's how you can complete the remaining one. Now let's start with the curves. The pictures that are the results of doodling are called curves. Generally the word curve can be, now in mathematics a curve can be straight. Here we will observe that the third and the fourth and the sixth. Now here first, second, third, fourth, fifth and these are our 6 figures. Out of all these, only the third one and the 7th one crosses themselves. That means where the curve do not cross, these are our those figures. Now the curve does not cross itself, that is called a simple curve, and where the curve does not cross themselves, these are the examples of our simple curves. Now open curve and closed curve. The curve that do not begin and end at the same point, they are called open curves. These are our examples of open curves. Now curves which begin and end at the same point are called closed curves. The adjoining figures, these are our examples of closed curves. Now position in a closed curve. In a closed curve there are 3 adjoining figures. The interior, that is the interior. The boundary, this is our boundary, and this is our exterior, that is outside. So A is the interior, B is the exterior and C is on the curve. So the interior of a curve together with its boundary is called its region. Now let's start with the polygons. Now simple closed curves which are having more line segments, they are called polygons. Polygons are further divided into various categories depending on the line segment they have. Now here see the following figures. Figure 1, 2, 3, they are polygons. Now let's look at the side, vertices and diagonals. Sides are the line segments forming a polygon, are called its sides. So here AB, BC, CD, D and E are sides. Vertices, the meeting point of a pair of sides is called a vertex. So here the side A and ED meet at E. So E is the vertex. So A, B, C, D and E are the vertices. Adjacent sides, any 2 sides with a common endpoint is called the adjacent side of a polygon. So in this polygon, AB, BC, BC, CD, CD, D and D, EA and EA, AB are our adjacent sides. Next is our adjacent vertices. The endpoint of the same side of a polygon are called adjacent vertices. So in this, the polygon A, B, C, D, E, vertices E and D are adjacent and A and D are not adjacent vertices. Other adjacent vertices are B, C, C, D and E. Diagonals. The line segment formed by joining the pair of vertices which are not adjacent are called the diagonals. Now in the polygon A, B, C, D, E, AC, AD, BD, BE and C are our what? Diagonals. Now here we have to classify the curves as open and closed. So here figure 1 and 3rd are open and otherwise all are closed one. Now in example number 7, in the following figures we have to name the points inside the figure or outside the figure. So in the first one, the points interior are L and K and exterior are P, M. Now here in the second one, interior are Q, A, L, F and exterior are M, R, P, N and C. Now let's start with exercise 6.2. In the first one, we have multiple choice question. We have to take the correct answer. A figure in which the initial and end point coincide with each other is a closed figure. That's how you can complete the remaining part. Now let's start with angles. When 2 rays have a common initial point, an angle is formed. The common initial point is called the vertex of the angle and the 2 rays forming the angle are called its arms or sides. An angle is represented by this symbol. Here are the working rules how to form an angle. In the step 1, we will draw 2 rays from the starting, that is from the same initial point. Then we will name them as OA, OB and these rays are our arms or sides of the angle. then an angle will be formed with O as a vertex, and this symbol is used to represent an angle, that is angle AOB or angle BOA. Now always remember, in naming an angle, vertex is always written in the middle. We can also name an angle by simply writing its vertex. For example, angle P angle, it can be denoted as angle P. In case two or more than angles share the same vertex, it is not possible to denote them by the vertex only. Now next is the interior and exterior of an angle. Now this is our angle XOY, and ray OX and OY divide all the points in the plane. Now here the shaded part is the interior of angle XOY, and all the points which do not lie in the exterior, they are called the exterior. Now the region of all those points which lie on, these are our arms OX and OY, and which are on the arms, that is called the common boundary of two regions. So in this figure, P and R exterior, Q is the interior, and OSXY, they are lie on the boundary of angle XOY. Now always remember, the arms of an angle separate its interior and exterior, and the interior of angle together with its boundary is called the angular region of an angle. Here is our example number 8. We have to name each of the following angle in 4 different ways. These are our 4 different ways: angle ABC, CBA, angle B, angle 4, angle PQR, RQP, angle Q and angle 2, angle XYZ, ZYX, angle Y and angle 3. In example number 9, in the following figure, we have to name the angles indicated by using the 3 letters for H. So first one is angle BAC or angle CAB, angle BAD or angle A. In the second one, it can be angle C or angle BCD or angle DCB. In the third one, it can be angle CDB or angle DBC. In example number 10, from the given figure, we have to find out the points lies in the interior of P, that is G and S. In the next one, how many angles are there in the given figure? That is angle BAC, CAD, angle DAE, angle EAC, angle DAB and angle EAB. Let's start with exercise 6.3. Here in the first one, multiple choice question, we have to take the correct option. A figure formed by 2 rays with a common initial point. A figure that is formed by 2 rays with a common initial point is an angle. That's how you can complete the remaining part. Next is our triangles. A closed figure bounded by 3 line segments is called a triangle. Here are our working rules that how we can form a triangle ABC. Now we will draw 3 points on a piece of paper, and then we will name them as A, B and C. Then we will draw the line AB, the line segment AC and BC. Then now a triangle is formed as shown in the figure. Now the triangle is named as triangle ABC, and this symbol is used to represent triangles as triangle ABC. Here are our parts of a triangle. A triangle has 3 sides and 3 angles. 3 line segments are AB, BC, CA, and 3 angles are angle B, angle A and angle C of triangle ABC. A, B and C are vertices of triangle ABC. Side BC is the side opposite to vertex A. Similarly, AB and AC are opposite to vertex C and vertex B. Vertices A, B and C are the vertices opposite to sides BC, AC and AB. And sum of all angles of a triangle is 180 degree. Now always remember, the 3 sides and 3 angles together are called the 6 elements or parts of a triangle. Now in triangle ABC, 3 angles can be denoted as angle A, angle B and angle C in case only angle is made at every vertex. The side opposite to angle A is denoted as A, side opposite to angle B as B and side opposite to angle C as denoted C. Now here is the interior exterior of a triangle. Now P is our interior, this is on the triangle, this is our triangular region and this is our exterior. Now if you draw a triangle ABC on a sheet of paper, it will divide all points on the plane into 3 parts. First is the part of a plane which consists all the points such as P, interior of triangle, which consists all the points such as R, that means forms the triangle itself. Interior of triangle ABC together with triangle is called the triangular region, and the part of the plane which consists points such as Q, they are called the exterior of the triangle. Now in example number 12, here in this triangle PQR, we have to name the side opposite to angle R is PQ. Angle opposite to QR is angle P. Vertex opposite to PR is Q. Side opposite to P is QR. Now in example number 13, we have to look at the figure and given it right and answer the following. Now name the points which are in the triangular region PQR, that is P, B, Q, A, R, L, O and T. Now which of these lie on triangle PQR? That is the same one. Now which points are lie in the exterior? That is M and N. Let's start with exercise 6.4. In the first part MCQ, here we have to take the correct option. The number of parts in a triangle is 6. That's how you can complete the remaining one. Now let's start with the mental maths. Number of triangles in the given figure that you have to tell me. Now let's start with the quadrilateral. A closed figure bounded by 4 line segments is called a quadrilateral. If ABCD are 4 points in a plane such that no 3 of them are collinear and the line segments AB, BC, CD and DA do not intersect except at their endpoints, then the figure formed by these line segments is called a quadrilateral. Now here are the working rules that how we can form a quadrilateral. We will take 4 line segments. We will join 2 line segments end to end. By joining them, one angle is formed. Now join the third line segment to the second line, then at its free hand. Now in the step 3, we will fix the fourth line segment such that it joins the first and the third line segment. In step 4, on joining the fourth line segment, it gives us a particular shape. Now we have taken all 4 line segments and then we will join them in a definite pattern to form 4 angles. So we call this quadrilateral as 4 sides. Now let's start with the side angles and diagonals. 4 line segments are AB, BC, CD and DA are its sides. The 4 angles, angle A, angle B, angle C and angle D are called angles. A line segment joining 2 consecutive vertices is called a diagonal. That means AC and BD are our 2 diagonals. Now adjacent sides and opposite sides. Now 2 sides of a quadrilateral are said to be adjacent if they have a common endpoint. Now 2 sides of a quadrilateral are said to be opposite if they are not adjacent sides. Therefore in the quadrilateral ABCD, AB and AD are the pair of adjacents, also are the pair of sides, that is AB, BC and BC, CD. Again in the same figure, AB and DC is a pair of opposite side and BC and AD is the other pair of opposite sides. Now next is our adjacent angles and opposite angles. 2 angles of a quadrilateral are said to be adjacent if they have a common side. 2 angles of a quadrilateral are said to be opposite angles if they are not adjacent angles. Therefore, in the above figure, angle A and angle B is a pair of adjacent angles in the quadrilateral and they have a common side AB. Similarly, angle B, angle C, angle D and angle D and angle A are other pair of adjacent angles. So again in the same figure, angle A and angle C pair of opposite angles also is a pair of angle B and angle D also. Now let's start with the interior and exterior of a quadrilateral. Now look at the joining figure. Do you observe? Quadrilateral ABCD divides all the points into 3 parts. So the first one is the part of the plane which consists of point PQR of the inside the quadrilateral, and that is called the interior of the quadrilateral. Now the points PQR lies inside, so PQ are our interior points. Now the part of the plane which consists of LMN outside the quadrilateral, they are called the exterior, and point LMN are exterior points. Now the quadrilateral itself consists of its sides and that is called the boundary of its interior. Next is our quadrilateral region. The interior of the quadrilateral ABCD together with the quadrilateral itself is called the quadrilateral region. Now in example number 14, here we have to take a point O inside a given quadrilateral PQRS. Then we will join the point O to the vertex PQRS. Now in what figures will the quadrilateral be divided into? We have to name the figures. So the figures are triangle POS, triangle ROS, triangle POQ and triangle QOR. Now in example number 15, in the figure ABCD is our quadrilateral. Now In the first one, how many pair of adjacent sides are there? We have to name them. So these are AB, BC, BC, CD, CD, DA and DA, AB. Now how many pair of opposite sides are there? We have to name them. So these are 2 pair of opposite sides, ABCD and AD, BC. Here we have to name the 4 pair of adjacent angle, that is angle A, angle D, angle D, angle C, angle C, angle B and angle B, angle A. Pair of opposite angles are angle A, angle C and angle B, angle D. Now let's start with exercise 6.5. In the first one, we have multiple choice question. Take the correct option. Two sides of a quadrilateral are said to be opposite sides if they have a common end point. That's how you can complete the remaining part. Now let's start with the chapter end exercise. Here in the MCQ, we have to take the correct option. A ray has one end point. That's how you can complete the remaining part. Now let's start with the mental maths. In the given figure, name all the triangles. Here you have to write all the triangles, that is triangle ABC, triangle ADC, triangle ABD, triangle ECD. That's how you can complete the remaining part. Here is the horse. How many planes will contain a line and a point not on the line? That you have to tell me here, and that's how you can solve the assertion and reasoning by yourself. Now I hope you have understood the chapter pretty well. You just have to practice exercise question and don't forget to revise this topic again.